Okay guys, welcome again. In this video I will explain how FHRP or First Hop Redundancy Protocol works and also discuss about Hot Standby Router Protocol or HSRP. Every host within the organization's network needs for a router as the default gateway when connected to the internet. But what if the gateway router goes offline or the default gateway IP is changed during configuration? Replacing the gateway router will cause a longer service interruption to the users within the organization, and that is not a reactive way to handle the issue. This is where FHRP will take place. This diagram is an example of a network topology without FHRP implementation. To ensure that a device will still have access to remote networks, you should implement some type of default gateway redundancy in the network. That is the role of first hop redundancy protocols. FHRPs enable you to install multiple routers in a subnet to collectively act as a single default router. These routers share a virtual IP address. As you see the diagram, one router is active router, which is forwarding the traffic coming from hosts in the organizations, and the other router is standby router. Standby router is a backup router when active router is filled, and the standby router takes over the responsibility to forwarding traffic coming from hosts. In the topology, the gigabit Ethernet 0/0 interfaces on router 1 and router 2 are configured with the IP addresses 10.1.1.1 and 10.1.1.2, which are the same subnet. However, both routers are also configured with the virtual IP address, which is 10.1.1.254. This virtual IP address is the default gateway address configured on the end devices. A redundancy protocol provides the mechanism for determining which router should take the active role in forwarding traffic. It also determines when a standby router must take over the forwarding role. The transition from one forwarding router to another is transparent to the end devices. This capability of a network to dynamically recover from the failure of a device and acting as a default gateway is known as a first hop redundancy. When the active router fails, the standby router stops seeing hello messages from the forwarding router, and also standby router assumes the role of the forwarding router because the new forwarding router assumes both the IP and MAC addresses of the virtual router. The end stations or end devices do not recognize a disruption in service. Okay, three main options available for FHRPs: Hot Standby Router Protocol or HSRP, a Cisco proprietary protocol designed to allow for transparent failover of a first hop IP version 4 device, also support for IPv6 networks. Virtual Router Redundancy Protocol or VRRP, an IETF standard that dynamically assigns responsibility for one or more virtual routers. Its operation is similar to that of HSRP. VRRP version 3 supports IPv4 and IPv6 networks. Gateway Load Balancing Protocol or GLBP, a Cisco proprietary FHRP that protects data traffic from a failed router as an HSRP and VRRP, while also allowing load balancing or load sharing between a group of redundant routers. GLBP for IPv6 provides support for IPv6 networks. The next part of video I will discuss about Hot Standby Router Protocol. HSRP uses an active or standby model in which one router actively assumes the role of default gateway for devices on the subnet. One or more routers on the same subnet are then in standby mode. Before forming the HSRP, each HSRP router will go through a number of states before it ends up as an active or standby router. That is what will happen. Initial state. This is the first state when HSRP starts. You will see this just after you configured HSRP or when the interface just got enabled. Listen state. In this state, the router knows the virtual IP address and will listen for hello messages from other HSRP routers. Speak state. The router will send hello messages and will join the election to see which router will become active or standby. Standby state. In this state, the router did not become the active router, but will keep sending hello messages. If the active router fails, it will take over. Active state. In this state, the router will actively forward packets from clients and sends hello messages. The HSRP active router implements a virtual IP address and matching virtual MAC address. This virtual IP address is part of the HSRP configuration and belongs to the same subnet as the physical interface IP address, but it is a different IP address. The router then automatically creates the virtual MAC address. All the cooperating HSRP routers know this virtual address, but only the HSRP active router uses these addresses at any one point in time. For example, you have two HSRP routers similar to router 1 and router 2. These HSRP routers send each other messages to negotiate which router should be active. Then they continue to send each other messages. For example, active router will send hello messages to the routers that are in standby mode. Routers in standby mode will listen to the hello messages so that the standby router can detect when the active router fails. If they do not receive anything from the active router, they will wait for the hold time to expire before taking over. The hold time is 10 seconds by default, which is pretty slow. I will show you in the next part and the configuration part how to speed up this 10 seconds. The standby router automatically assumes the virtual IP and MAC addresses and serves as the default gateway for the LAN. The new active router then sends out an out packet so that the switches on the subnet will change their MAC address tables. This failover process is transparent to end devices, which are all configured with the virtual IP address as the default gateway. And also HSRP use priority and preemption. By default, the router with the numerically highest IPv4 address is elected as the active HSRP router. To configure a router to be the active router, regardless of IPv4 addressing, use the standby priority interface configuration command. The default priority is 100. The router with the highest priority will be the active HSRP router, assuming that no election has already occurred. Remember, to force a new HSRP election, preemption must be enabled with the standby preempt interface configuration command. So what about load balancing? Aren't we wasting the capacity of the standby router and the links connecting to it? Yes, if the routers are connected to only one subnet. However, if VLANs are configured, The routers can share the load by each serving as the active router for some of the VLANs. For example, in this diagram, router 1 is the active router for VLAN 10 and router 2 is the active router for VLAN 20. Both routers are configured with subinterfaces for inter-VLAN routing and the two virtual IP addresses so that each can assume the role of active router if the other router fails. There are two versions of HSRP, and this table shows you how the difference between HSRP version 1 and version 2. You can change the version by using the standby version command. I hope this information is useful to you, and I want to thank you for watching this video. If you like this video, please subscribe my channel.